Hello guys and welcome to a new video. In this video we're going to talk about a very important concept in programming called recursion. So the idea of recursion is that you have a method that calls itself and it will call itself multiple times, and essentially there are some math problems that are built on recursion, and I know a lot of employers they ask a lot of recursion questions when they do their interviews. So it's a really important topic, and hopefully you will be able to understand it really well. So before we do recursion, we're just going to start with a simple example that has nothing to do with recursion, and then we're going to modify our example so we actually have recursion. So essentially, imagine you have a math function, really simple, so nothing hard. Imagine you have f of n equals n times 2. So you have a function takes an integer number n, and then the value of the function is going to be n times 2. So for instance, if you do f of 7, it's going to be obviously 14, and you'll get that for any other value. So we're going to actually go ahead and implement this function in Java, and then we're going to modify it to actually look into recursion. So to do that, essentially what you need to do is define your method. So public static integer. So essentially we're going to be returning an integer. Let's actually name it f as well. So we're actually taking integer number, and then we're returning whatever that number times 2. So to check, essentially you have for n equals like 3. We're just going to pass like really simple values. The result is f of 3. Then we're actually going to copy this one more time. For n is 6, the result is f of 6. So let's run this. n3, 6, 12. It seems to be good. Now this example is clearly there is no recursion because the value of the function depends on whatever n you pass, you multiply by 2. Now let's actually modify this function a little bit and see kind of how we make it a recursive function. So now if I say f of n is going to be f of n minus 1 plus 2, for example, how would we do that? So now if you think of this case, if I have, for example, f of 3 is going to be f2 plus 2. But what's f2? f2 is going to be f1 plus 2. So essentially now you can see the value for a function at a particular value is dependent on the value of the function for a completely different value. So that's essentially where the recursion is. You cannot get the value from kind of like one instance, because that instance would need the value of another instance. So you will have a chain of requests between, like in your code, the method calling itself, until essentially your method is going to be able to give you the final result back. So for this reason, you need to have something called like a base case, like at the very simple case, what's going to be the value. So in this example, let's assume that f of 1 is equal to 100. So although I'm looking for something like f3 or f6, essentially I know that my program is going to keep asking for new function values until ultimately it will know, oh yeah, f1 is 100, so now it could go up and be able to retrieve those values. I actually put these as in a Word document, so let me paste them in here as a comment. So now, given what we have, so to compute f of 3, f of 3 is going to be equal to f of 2 plus 2, but what is f of 2? That's going to be f of 1 plus 2. But we know that f of 1 is 100, so now f of 2 is going to be 102, f of 3 is going to be 104. So now here is kind of like the chain I was just talking about. So for f of 3, you need to know f of 2, and then for f of 2, you need to know what f of 1. Once the data for f of 1 is available, now essentially you need to go up in the chain so that you pass the data back to the requester. In this case, f of 3 requested some information, and then f of 2 requested another information until basically the information was available from f of 1. Now we go on reverse. F of 1 has the information, sends it back for f of 2, which in turn sends it back for f of 3. So hopefully that will make it clearer. So now, again, in order to make this function a recursive function, we need to pretty much just take these two cases over here, and then I'm just going to actually copy them and implement them down in our method. So our function still takes an integer num, so no changes in there. But now I need to actually implement the base case. So for the base case, let me just actually add this as a comment. My base case in here, I'm going to say, well, if num is equal to 1, well, essentially, I'm going to set, kind of like have a return in this case, return 100. So if num is equal to 1, return 100. But what if num is not equal to 1? So you can have like an else. So if num is not equal to 1, just like in this example, so for f of 3, you wanted to know f of 2. So for num, I need to know num minus 1. So in that case, it's just going to be return f of num minus 1 plus 2. That's essentially what my function actually says. F of n is f of n minus 1 plus 2. So now let's see what actually, if I do f of 3, for example, for f of 3, we're getting 104. For n equals 6, we're getting the result is 110, which is good. Now, we cannot at this point see what's happening inside of our function, so we know there is going to be multiple calls for this f. So actually, let me kind of change this a little bit so you kind of can see what's happening. So I will define int result. That's going to be this one. And I will return result. But inside of this one, the else, I will have a print out statement. So you kind of can see how many times this is printing. Remember, if you make your program really general, really abstract, with no printing, everything is going to be running in the background, and you won't be having the chance to see how many times certain lines of your code are executed. So it's a really good practice. Every time when your program is giving you something you're not expecting, or if you want to know more about the logic of your program or someone else's code or whatever it is, always add print line statements, because this is going to be really helpful for you to see what's happening. We know, for instance, this f is running multiple times, but let's see how num actually is changing. So num is num, and let's also print the result. Then result is result. So see, we're actually running this method a couple different times. N is a 3, and then n is 6. Let's see what's happening. So num is actually 2. So num is whatever I'm passing. So I passed with 3. Essentially, what's happening is we started obviously with like 2, and then essentially when 2 is available, the result was 102, because we cannot calculate f of 3 because we need to get f of 2. And then when f of 2 was available, essentially we passed again the result back up for num is a 3, and the result was a 104, so we got 104. For the other one, when we passed f of 6, f of 6 wants to know f of 5, f of 5 wants to know f of 4, f of 3, f of 2, f of 1, which we know is 100. So now at that point, num is equal to 2, and then we got the result. Num is 3, result is 104, num is 4, 5, 6, and that's the result we got back. So this was something we got because we actually printed this, and I really highly encourage you guys to keep adding print line statements in your code, especially as your program gets more sophisticated and you have a chance to kind of uh, add things over and see how your program will react. Something like this is really important, and in fact, it's actually part of something called debugging your program, which is kind of like step-by-step execution of your program and seeing how the program kind of like data changes internally within the program. Okay, so hopefully that was helpful to you guys, and I will see you in the next one. Bye bye.